Welcome to today's space adventure, the Hubble Space Telescope. The Hubble Space Telescope was launched into orbit by Space Shuttle Discovery on April 24, 1990. Hubble orbits about 535 kilometers, 332 miles above Earth. It is the length of a large school bus and weighs as much as 2 adult elephants. Hubble travels about 5 miles per second. That is like traveling from the eastern coast of the United States to the western coast in 10 minutes. Hubble is solar-powered. Hubble takes sharp pictures of objects in the sky such as planets, stars and galaxies. Hubble has made more than 1 million observations. These include detailed pictures of the birth and death of stars, galaxies billions of light years away, and comet pieces crashing into Jupiter's atmosphere. It was not the first space telescope, but it is one of the largest and most versatile, renowned both as a vital research tool and as a public relations boon for astronomy. Hubble features a 2.4 meters, 7 feet 10 inches, mirror, and its 5 main instruments observe in the ultraviolet, visible, and near-infrared regions of the electromagnetic spectrum. Hubble's orbit outside the distortion of Earth's atmosphere allows it to capture extremely high-resolution images with substantially lower background light than ground-based telescopes. It has recorded some of the most detailed visible light images, allowing a deep view into space. Many Hubble observations have led to breakthroughs in astrophysics, such as determining the rate of expansion of the universe. Hubble has made more than 1 million observations. These include detailed pictures of the birth and death of stars, galaxies billions of light years away, and comet pieces crashing into Jupiter's atmosphere. Scientists have learned a lot about the universe from these pictures. Many of them are beautiful to look at. Space telescopes were proposed as early as 1923, and the Hubble telescope was funded and built in the 1970s by the United States Space Agency NASA with contributions from the European Space Agency. Its intended launch was in 1983. But the project was beset by technical delays, budget problems, and the 1986 Challenger disaster. Hubble was finally launched in 1990, but its main mirror had been ground incorrectly, resulting in spherical aberration that compromised the telescope's capabilities. The optics were corrected to their intended quality by a servicing mission in 1993. Hubble is the only telescope designed to be maintained in space by astronauts. 5 Space Shuttle missions have repaired, upgraded, and replaced systems on the telescope, including all 5 of the main instruments. The 5th mission was initially cancelled on safety grounds following the Columbia disaster, 2003, but after NASA Administrator Michael D. Griffin approved it, the servicing mission was completed in 2009. Hubble completed 30 years of operation in April 2020 and is predicted to last until 2030 to 2040. Earth's atmosphere alters and blocks the light that comes from space. Hubble orbits above Earth's atmosphere, which gives it a better view of the universe than telescopes have at ground level, which makes Hubble different from telescopes on Earth. Hubble is named after an American astronomer, Edwin P. Hubble. He made important discoveries in the early 1900s. He showed that the galaxy containing the solar system, the Milky Way, was only one of many galaxies. His work helped show that the universe is expanding. This led to the Big Bang theory, which says that the universe began with an intense burst of energy and has been expanding ever since. Within weeks of the launch of the telescope, the returned images indicated a serious problem with the optical system. Although the first images appeared to be sharper than those of ground-based telescopes, Hubble failed to achieve a final sharp focus, and the best image quality obtained was drastically lower than expected. Images of point sources spread out over a radius of more than 1 arcsecond, instead of having the point spread function, PSF, concentrated within a circle 0.1 arcseconds, 485 μ, in diameter, as had been specified in the design criteria. Many feared that Hubble would be abandoned. The design of the telescope had always incorporated servicing missions, and astronomers immediately began to seek potential solutions to the problem that could be applied at the first servicing mission, scheduled for 1993. While Kodak had ground a backup mirror for Hubble, it would have been impossible to replace the mirror in orbit, and too expensive and time-consuming to bring the telescope back to Earth for a refit. Instead, the fact that the mirror had been ground so precisely to the wrong shape led to the design of new optical components with exactly the same error but in the opposite sense, to be added to the telescope at the servicing mission, effectively acting as spectacles to correct the spherical aberration. Since the start of the program, a number of research projects have been carried out, some of them almost solely with Hubble, others coordinated facilities, such as Chandra X-ray Observatory and ESO's Very Large Telescope. Although the Hubble Observatory is nearing the end of its life, there are still major projects scheduled for it. One example is the current Ulysses project, Ultraviolet Legacy Library of Young Stars as Essential Standards, which will last for 3 years to observe a set of high and low mass young stars and will shed light on star formation and composition. Another is the Opal project, Outer Planet Atmosphere's Legacy, which is focused on understanding the evolution and dynamics of the atmosphere of the outer planets, such as Jupiter and Uranus, by making baseline observations over an extended period. The program, officially named Hubble Deep Fields Initiative 2012, is aimed to advance the knowledge of early galaxy formation by studying high-redshift galaxies in blank fields with the help of gravitational lensing to see the faintest galaxies in the distant universe. Among its primary mission targets was to measure distances to Cepheid variable stars more accurately than ever before, and thus constrain the value of the Hubble constant, the measure of the rate at which the universe is expanding, which is also related to its age. Before the launch of HST, estimates of the Hubble constant typically had errors of up to 50%, but Hubble measurements of Cepheid variables in the Virgo cluster and other distant galaxy clusters provided a measured value with an accuracy of ±10%, which is consistent with other more accurate measurements made since Hubble's launch using other techniques. The estimated age is now about 13.7 billion years, but before the Hubble telescope, scientists predicted an age ranging from 10 to 20 billion years. The high-resolution spectra and images provided by the HST have been especially well suited to establishing the prevalence of black holes in the center of nearby galaxies. While it had been hypothesized in the early 1960s that black holes would be found at the center of some galaxies, and astronomers in the 1980s identified a number of good black hole candidates, work conducted with Hubble shows that black holes are probably common to the centers of all galaxies. The Hubble programs further established that the masses of the nuclear black holes and properties of the galaxies are closely related. There is no direct replacement to Hubble as an ultraviolet and visible light space telescope, because near-term space telescopes do not duplicate Hubble's wavelength coverage, near ultraviolet to near infrared wavelengths, instead concentrating on the further infrared bands. These bands are preferred for studying high redshift and low temperature objects generally older and farther away in the universe. These wavelengths are also difficult or impossible to study from the ground, justifying the expense of a space-based telescope. Large ground-based telescopes can image some of the same wavelengths as Hubble, sometimes challenge JWST in terms of resolution by using adaptive optics, have much larger light gathering power, and can be upgraded more easily, but cannot yet match Hubble's excellent resolution over a wide field of view with the very dark background of space. Plans for a Hubble successor materialized as the Next Generation Space Telescope project, which culminated in plans for the James Webb Space Telescope, JWST, the formal successor of Hubble. Thanks for watching. If you liked the video, press the like button, subscribe our channel and press the bell icon to get the next video notification. To cosmos, infinity, and beyond. See you in next space adventure.